Hello friends, you are watching Data Structures using C. All the videos are brought to you by Ankpro Training from Ankpro Technologies. Friends, in this class we are going to study the different types of linked list. So if you are new to this video, please go and watch our previous videos on linked list and other data structures. So in the last class, in the last video, we have learned the single linked list and the memory representation and the operations of the single linked list. And today we are going to learn the other types of linked lists. So this is already done. So there is a circular linked list, which is the second type of the linked list, and the doubly linked list, which is the third type, and the circular doubly linked list. Right. So these are the four types of linked lists. One is already done. So let us go and study the second type of linked list called circular linked list in this video. Okay. So this is also a linked list, but the last node makes the linked list circle by storing the address of the first node. Normally in the linked list, the last node in the list contains null in place of pointer. By that, it represents itself as the last node in the cell, right? So that is the terminating node in the list, right? So if that is connected back to the first node, it makes the circular linked list. By that, all nodes are linked in a continuous circle. So let us look at the structure of the circular linked list. So there is a start pointer which points the first node in the linked list, which has got 1000 and a data 10. So this stores the address of the next node. So likewise, there are 4 nodes in the list. So the last node here hasn't got null in place of pointer, but it stores the address of the first node. So 1000 is the address of the first node. So it is pointing back to the first node, right? So look at this, 1000 is the address of this node, and this is stored in the last node, right? So while working with the circular linked list, we don't use the start pointer, rather we use a pointer called last, which stores the address of the last node. So here the address of the last node is 1006, and that is stored in the last pointer. Why we are using the last pointer in case of circular linked list? This is useful because by referencing the last node, we can access the last node as well as the first node. Since the last node contains the address of the first node, we are just one node away from the first node, and we are currently pointing to the last node. So if we want to traverse throughout the circular linked list, we just go here and access the first node and the second node and the subsequent nodes. If we want to access the last node, so here we got the last node address. If we want to access only the first node, here we got the first node address. So by accessing the last node, by storing the address of the last node, it is very helpful to access all the other nodes in the circular linked list. So that is why instead of start node, we are using the last node in the last pointer in the circular linked list, right? So what are the operations? So here in this video, we are going to study all these operations. One is createList, which takes the pointer, last pointer, address of the last pointer, and display function, which displays all the nodes in the list. So there is a function which adds a node in the empty list. We can also add the node in the non-empty list. We can add at the beginning. We can also add at the end. We can add node after any node, and we can delete any node in the list, that may be first, last, or any other node in the list. So let us study the C code to display circular linked list. So we'll start by analyzing the display function first. Later on we will go and analyze all the other functions. You don't miss any function in this video. We will study each and every function regarding circular linked list. So let us assume this as our circular linked list which has already been created, and now we are going to study the display function, right? So void display, it takes the address stored in the last pointer. So by knowing the address stored in the last pointer, we can access all the other pointers, because the address stored in the last pointer is the address of the last node, right? Okay. So struct node star t. Here t is a temporary pointer variable which we need only for this operation. Okay, so let us create that t. So here we have got a t variable. If last equals to null, so if this equals to null, that means the list is empty, right? So in the beginning, if there is no node in the list, by default last has got the data null. That means there is no node in the list. So in that case, we will tell the user list is empty, right? There is still the pointer t. Else, if list is not empty, we will store the content of last in t. Last arrow next means last of this. So this is next. Next means the address of the next node. So last arrow next represents 1000. So that is stored in t. So now t is, yes. If t pointer holds last node next means t is currently pointing to the first node, because last arrow next means 1000. Here next is same as the pointer which references the next node in the list. I mean, in this case, the first node in the list. So here t is currently pointing to this node. Okay. So if that is true, do. Why we are using the do while? Because we have to traverse all the nodes, right, to display all the nodes. Printf t arrow data. T arrow data means the data part of this node. Okay, that is printed. Now t arrow next. So t arrow next means this part. So now t is incremented. So what is the content of t now? T arrow next. That is 1002. So now t is pointing to this node, right? So this will work until t remains not equals to last arrow next. So this will iterate every time t prints the data, and it will incremented by t arrow next every time. And whenever it reaches here, whenever t reaches here, t arrow next, that means this part. So this is not equal to, t not equal to this thing, you repeat the loop, right? So in the last iteration, this points to this, t points to 1000. At that time, this holds not good, right? So while loop expires, and you will come out of the loop by displaying all the elements, all the nodes in the list. Okay, now we will understand the C code to create a circular linked list. So far we have assumed that the linked list has been created, and we have traversed throughout the linked list. So we will learn the code to create a circular linked list, right? So just look at this. So struct node createList will create a new circular list of n number of elements. Okay, that is fine, and it takes the last pointer as an argument. If you provide in the function called the last pointer the address of the last pointer, I mean it may be null or anything, so it takes that and starts creating the nodes in the list. Okay, so here I have three variables. I'll use this I in for loop. N is the total number of nodes that I'm going to be created, and value is the value that is going to be inserted in every node of the list. Okay, so I'll ask the user how many values you want to enter. So he says n, and enter the first data for the list. Right, he will enter the first data which is stored in value. So n is the total number of nodes and value is the data for the first node. Right, so I will pass the last pointer and the value to the function addToEmpty. So addToEmpty is a function which creates a node when the list is empty. The list is empty, so I'll pass the last pointer and the value to create a new node. So let's go and check that. So this is addToEmpty function. So here it is taking the last pointer and the value. Let us assume that here we have got just this much, right? So the last pointer has got null in it because we have defined it globally, right? So last pointer has got null and null is returned here, and the value which I have passed from the createList function. Okay, so n is a temporary variable here, so let us create that n pointer. Right, so this is the n pointer and this will hold the address of the newly created node. So I'll use the malloc function. So malloc function will allocate a memory block or create a memory block calculated by the size of function. So ultimately it calculates the memory block required for one node which is of type struct node, and it will return the memory address of the newly created block. Right, okay, I'll erase this. So this is, yeah, okay. And what's next? So n stores, now n has got the address of the newly created node. So let us say suppose this has been created. So this has been created but not initialized. Okay, so this is ready now. So now I'll store n arrow data. Inside of n arrow data I'll store the value. So now value goes inside n arrow data. That means here I'll store the value which I've taken from the createList function. Last equals to null. So here now I'm storing the value, the memory address of this node inside last variable, right? So now last is pointing to this node. So because I have stored the content of n into last, right? Last of next equals last. Here this is the last of next, right? So next is the pointer which points to the next node. So this is now currently pointing itself because last arrow next is equal to last, whatever I have here, right? So the address of this node is storing here. So I'll store the address of the same node in last arrow next. That means here. So this arrow, I mean this node is currently pointing itself and return last. So now I'll return this last to the calling function. Okay. Okay, so this has been done. Now we have got a node. So let us say suppose this is start. So this is start and it has got 1000. So 1000, this node is currently pointing itself, right? Now, so now I start creating the other nodes. I initialized I with 2 because one node is already created. I'll start from 2 and I will make I remain until it is less than or equal to n, because I have to create n number of nodes and I've already created one node here which is currently pointing itself, and I want to create n minus 1 nodes. For that I'm initializing I with 2. Okay, now I'll ask the user enter the next data and I'll store that in value. Now I'll call addAtEnd function. addAtEnd will create a new node at the end of the list. Currently we have this much of list. Now whenever I call this addAtEnd function, it will create a new node at the end of the list like this. So it is going to be created like this. Let's go and check that function. So here it is. So currently assume that it is not yet created. So this is what we have got right now. Okay, so this will take the last pointer and the value to be inserted in that node. So I've created one pointer variable n, and it will create a new node of size calculated by size of function, and that is stored here. So let us say suppose this has been created now. So one node has been created, and I'll store the value inside n arrow data, I mean here. So now I'll store the address last arrow next. So this will be the last node. It has to point to the first node back, right? So it has to store the address of the first node inside here. So for that, I'm telling the content of last arrow next. That means the address of this. This is the address of the first node. So I will store last arrow next, the address of the first node inside n arrow next here. So now I'll store 1000 here, right? So now it is pointing to the first node, right? And last arrow next will now point to the first node, and the content of n will be stored in last arrow next. Here, this is the last arrow next. Here inside the content of n, I mean the address of the newly created node. Now this node is pointing here, and this node is pointing here. This is no longer existed, right? So by doing this, I made this node as the last node, and this last node is pointing to this node, right? Okay, so I'll store n again in last node. So the content of n, the address of n in last node, and I mean in the last pointer, and I'll return the last, right? So this is what happens. So that will be returned to the last. Okay, and this will be iterated until I remains not equal to n. So I successfully created n number of nodes. Okay. So this is the code for addToEmpty, and this is the code for addAtEnd, right? Now we'll understand the code for addAtBeginning. Let us assume there are already some nodes in the list. Now we are going to add a node in the beginning before the first node, right? So it will take the value to be inserted in the first node and the content of the last pointer. So let us assume this is the last pointer and this is the last node, and I want to insert a node at the beginning, right? So I'll take a new pointer called n, and this will create a new node, and the address of the newly created node will be stored inside n. So let us assume that this is newly created, okay, and n arrow data will store the value. Let us say suppose I have stored 20 in it, and the address of last arrow next last arrow next means the first node, right? So this is the last arrow next. This will hold the address of the first node, so that will be stored back into n arrow next here, right? So this will point to the first node. And next I'll store the address of n in last arrow next here. So I'll store the address of n inside the last arrow next. So now the last node is pointing to the first node, and return last. Okay, now we'll understand the code for addAfter, right? That means we're going to add a new node after any particular node, right? So this function addAfter function will insert a new node after the specified node. So this will take the last pointer to traverse throughout the list, and the value which is going to be inserted in the new node, and the item. So item represents the data present in the node after which we are going to insert the new node, right? So for that I'll use two pointers, t and n. So now I created two pointer variables, and now I will store last arrow next inside t. What is last arrow next? So let us assume this list has been created, and I'm going to create a new node, add a new node after any particular node. So I'll store the last arrow next, that means 1000 inside t. If I do that, t will start pointing to the first node. Why am I doing this? Because to insert any node, I have to traverse from the beginning to the end to identify or to find out that node, after which I'm going to insert the new node. So to do that, I'll traverse throughout the list. So for that, I'll use the do loop to traverse from the first node to the last node. If the match is found, if t arrow data equals to item, say suppose this is equal to the item. So say suppose this node is the node after which we are going to insert the new node. If that is happened, I will create a new block using malloc function, and I'll store the address inside n. Okay, so I've created a new block here, and this is the next pointer. So I'll store the value inside n arrow data. Here I've stored the value, and now I'll store t arrow next inside n arrow next. What is t arrow next? The address of the second node. So I'll store this inside n arrow next. By doing that, n will start pointing to the next node, because this has to be in the middle of first and second, right? Okay, and I'll store the newly created node's address inside t arrow next. So this will start pointing to n. So this will no longer be existed. So assume this. The first node is pointing to the newly created node. The newly created node is pointing to the third node. So this will happen whenever t arrow data matches with item. Right. What if t is equal to last? Say suppose, just a minute, I'll erase this everything. So this has not happened, this has not happened, nothing has happened. Okay, let's assume. Okay, so t is now currently pointing to the last node, and t is matched with 1000, right? The data has matched here. So this has already been created, value is stored. I'll simply store the newly created address inside last. So now last will point to this thing, right? And obviously this will point to the previous. And every time I'll make t to point to the next node by replacing the address inside t, right? So this will happen until t not equals to last of next. So this thing happen until it is not equal to last arrow next, and I'll tell %d is not in the list. So if it is not equal, if this is not happened, what is that? If t arrow data is not equal to item, I'll tell %d is not in the list, right? This is how we can add a node after any particular node, right? And friends, now we will see the code to delete any node in the list, right? So this is a little big program, so I've taken this code presenter here. So this will take the last pointer and the value which is to be deleted, and I will create two temporary variables t and p, which is both are pointers. If last equals to null, if this contains null, then there is no node in the list, so list is empty, right? So this code works. When there is only one node, right? Say suppose there is only one node, that means this. So if I pointing this to delete, first let me check. Last equals to last arrow next. Last equals to last arrow next. That means is there only one node? And last of data equals to value, and last arrow data is matching with the value that I want to delete. So if both gets true, I'll simply store the last inside t. So whatever this, so this means t is now pointing to the last node, and last equal to null, I'll store null inside last and free t. I will free this t, so that means t is now currently pointing nothing, and I'll return last, right? Say suppose to delete first node, if the match is found here, if I wanted to delete the first node, I will first check last arrow next arrow data. Last arrow next means this, arrow data means this, is matching with the value I want to delete. If that is true, I will simply store the last arrow next, that is 1000. I'll store the 1000 inside t, and I will store t arrow next inside last arrow next. That means t arrow next is this. I will store this address inside t arrow last arrow next. That means, so now last arrow next will point to this node, and I can simply free this t, right? And I'll return the last. If neither case is working, I will go for my default condition. If I found the match in anywhere in the middle of the list, so I'll simply copy the content of last arrow next inside p, and p arrow next not equals to last. That means I'll iterate through the list until p arrow next remains not equal to the content of the last. That means until I reach the last node. I'll check whether p arrow next arrow data, that means this thing, p arrow next arrow data, is this equal to value, because we have already checked this, right, in the previous case. If this is equal to value, I'll simply store the address of p arrow next inside t. I'll simply store the address inside t, and I'll store the t arrow next inside p arrow next. T arrow next is this, so this I'll store here. So this thing will point to this thing now, because this is free now, and I'll simply free t, and I'll return last. And every time, see here, every time p will increment pointing to the next slide, right? So this case is for to delete the last node. Let us say, so p is pointing to the previous node. In the last case, it remains here. So if last arrow data is equal to value, if this is equal to the value I want to delete, so I'll simply store the content of last inside t. Now t is currently pointing to last node, and p arrow next, and I'll store the last arrow next inside p arrow next. That means now currently p is pointing to the first node, and I'll store content of p inside last. Content of p inside last means now last is pointing to this, because address of this node is stored in p, right? And I'll simply free t, so this is no longer existed. If none of this is true, I'll simply tell %d is not found. That means value is not found. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.